Right, so what is a potentiometer and how does it work? Well, here we've got a very simple potentiometer. It's represented by the green wire in the circuit and the fly lead. That's the cable with the arrow drawn that comes out of the bulb. Now what we have here is a bulb, as with the potential divider, and the bulb cannot take all the voltage, all the potential difference that's provided by the cell. So we have to try and split that potential somewhere. So this is really, a potentiometer is a type of potential divider. Now, usually it's a piece of wire. It's normally wrapped around a coil, a tight coil, across a solenoid, and it always has this movable fly lead, this movable lead that you can slide up and down. And by moving it, you can actually change the values R1 and R2. Now, R1 plus R2 in this case is fixed. The total resistance in the circuit, R1 plus R2, is always fixed. It's always the same. But we can change how big R1 and R2 are with relation to each other. So if we slide that fly lead to the right, R1 gets bigger, R2 gets smaller, okay, and vice versa. Now, if I want to find out the potential difference across the bulb, V1, then what I have to do is I'd have to consider the current, which is the same all the way around the circuit, multiplied by R1, because V equals IR. Now, the current I also know is the same as the voltage across the terminal, so VT divided by the total resistance, because again V equals IR. I've just rearranged it to get I equals V over R. So I end up with that there. Now those two formulas, if I take the right hand formula, I equals VT over total resistance, and remember that total resistance is R1 plus R2, and I substitute that back into V equals IR1, I end up with the formula here in red. Now, if you cast your mind back to resistivity, resistivity, remember, is a property of a material that gives it or describes it how resistant it is to electrical current. I can remember that resistance equals rho, that's that resistivity symbol, times length divided by area. So I can replace R by resistivity, and the length, the L1 indicates the length of the wire to the left of the fly lead, and L2 indicates the length of the wire to the right of the fly lead. And it looks a bit ugly there, but if I factor it up a bit, what I find is I end up with, if I simplify it, I end up with a formula there again in red on the very bottom line. Now, if you notice the similarities there between the two red formulas, V1 equals, are absolutely, they're obvious. Because the resistivity is constant, the area is constant, I can simply replace R1 and L1 with each other, as the ratio between the two factors is identical. Now, we don't normally like to draw wires like this, so this is a potentiometer. Generally, instead of that, because R1 plus R2 is a fixed resistor, we tend to draw them like that. The important bit here is that the potentiometer, the box on its own is a fixed resistor, but the potentiometer part is this movable fly lead, this arrow that indicates I can slide that arrow up and down to the left or to the right and change R1 and R2. And that's what a potentiometer is. It's just a fancy type of potential divider.